Hello everyone. Today we're going to be talking about the 3 cards, 3 lines portion of the Spot It activity. The goals of the spotted activity in general, and maybe this one in particular, are to explore the implications of the n equals 3 Spot It game, and to encourage abstract reasoning while we do this. Before this activity, you will have looked at the n equals 3 Spot It game, and you will have hopefully constructed these 3 cards. And, maybe you have different colors, but you should have 3 cards, 2 colors each. Now the first step is on this worksheet, we want to go ahead and take our cards and place them into this diagram we have. So maybe I might take red and green and put that one right there. I might take red and blue, and I'll put that one right down there. And take this one, move it right there. Perfect. And now, key observation about this is that, because each of the 2 cards share exactly one color, each of these lines kind of corresponds to a color. So, for example, this card has a red, and so does this card, right? The thing they have in common is a red chip. So there's sort of a red commonality going on here. Same thing for these 2 cards. They have exactly one color in common. It's green. And so you can kind of think of this edge as being the green edge. And lastly, the last 2 have blue in common, and that's kind of blue. Okay. So now what we're going to be doing is we're going to be sort of contextualizing this relatively abstract game into people's traits. So you'll think of 3 people traits, and we'll assign each to each color. So I did this ahead of time. So for red, I said has a dog. G likes hiking, and B has a brother. So these are 3 people traits. And it's nice that these are binary. So they're just yes or no, and that's also important. And we want to see if we can find people such that there is exactly one card where both traits apply to that person. Okay, you might need to fudge your traits and find some people to make this work, but let's say that we found 3 people, Lupe, Ruth, and George. And I know that Lupe has a dog, and Lupe likes hiking, but Lupe does not have a brother, only child. And then maybe Ruth also has a dog, but doesn't like hiking, but does have a brother. And let's also say that Joe doesn't have a dog. Joe's a cat person, but Joe does like hiking, and Joe does have a brother. Okay, now let's check to see that these people are the ones that we need to satisfy part A. All right, so Lupe has red and green but not blue. Well, that makes it look like this is Lupe right here, right? Red and green but not blue. Okay. Ruth is red and blue but not green, which I think that's this one right here. And Joe is green and blue but not red. So it does look like each of these 3 people, if we assign these traits to these colors, has exactly one card where both of those traits in the card apply to them. The table is a helpful tool for this to really help you kind of sort out what's going on. But feel free to let the students explore through this problem. Okay, so now we want to change it up a bit, and we want to have a different requirement. So we want to change the traits, and we want to focus on part B. We want to find, so that for each person there's exactly one card that none of the traits apply to these people. Okay, so we're going to stick with Ruth, Lupe, and Joe, and we want to see if we can find some traits such that this holds. Okay, so let's say we played around and we found some of these traits, and as we're sort of recording Lupe, Ruth, and Joe's their preferences here, I know that Lupe loves ice cream. So Lupe does not dislike ice cream, right? And Lupe does like playing sports, but Lupe doesn't know Italian. Okay, and then similarly, if we fill this out, Ruth, Ruth doesn't like ice cream, not an ice cream person. But Ruth doesn't play sports and doesn't know Italian. Joe knows Italian, also not an ice cream person, also doesn't play sports. Okay, so let's see. We're kind of doing sort of the converse of the previous one. Lupe doesn't have red and doesn't have blue, but has green. Okay, so no red, no blue, has green. So we doesn't have red and green, so that's this one, Lupe. Because remember, we want exactly one card such that none of the two traits apply to that person, right? So red doesn't apply to Lupe. Blue doesn't apply to Lupe. Sorry. So it actually should be that card there. Similarly, Ruth does not have green and does not have blue. Green and blue, that's this one, right? Right there. So that's kind of Ruth's card. Ruth does not have green and does not have blue. And Joe does not have red or green, so that's Joe's card. Okay, this one's a little funky to kind of keep all the none of these, all of these sort of straight, but I think it does help to kind of keep a table to keep track of what's going on. All right, the last question is the trickiest. Can you make it so that for each person there are exactly two cards, such that for each of these cards, both traits apply to the person? Okay, it's an absolute tongue twister. But let's see if we can break this down. So for each person, there are exactly two cards. And the key word here is exactly. Exactly two cards, such that for each card, both of those traits apply. So let's play around with this a little bit. So let's say, let's pick a person. Let's pick Lupe. And let's say that Lupe has exactly two cards. Let's just, for now, let's pick these two cards. These are Lupe's cards. And then each of these cards, both traits apply to that person. Okay, so this tells us that Lupe has trait red, because red is red's in both cards, so Lupe definitely has red. It also says that Lupe has blue, because blue is in this card and Lupe has that card. Okay. And it looks like Lupe also has this card because Lupe is green. Okay. So Lupe has all three traits. And actually, if we did this for Ruth and Joe too, we would see that they also get all check marks. And we're thinking, okay, this is great. This is fine. We found the two cards, but there's a problem. And it's that key word that I mentioned earlier. It's exactly. Right? Because Lupe has red, green, and blue from these two cards here, well, there's another card that has those colors. It's this one. It's got blue and green. Right? So because Lupe picked up a blue from this card and a green from this card, she has those two traits, so she also has this card. Now that's a problem because now this is 3 cards for Lupe. And that's bad because we wanted exactly 2. So C is actually impossible. I recommend keeping the fact that it's impossible a secret because there's a lot of productive struggle that can go into this part C. And once students start to see, oh God, it's impossible, ask them why. How do they know it's impossible? And that's really where the meat and potatoes is. And you can kind of use this argument here. There's also sort of like argument by contradiction that you can do. But reasoning through this and trying to make sort of abstract reasoning from this context using these diagrams is very, very good for mathematical intuition.